We are going to be working through some trigonometry equations here, functions that we're going to try to graph. I have the steps that are used to help us. Here is like a general form. I have sine in here. This also works for cosine and tangent, although as we'll see a little bit later, tangent is a little bit different because of the period. So here we go. We want to graph y equals 4 sine of 4 theta. So what I'm going to do is I'm going to put down all my different things here. I want to find phase shift, which remember is our left to right movement. We also want to find, and we do it in this order, we're going to talk through period, amplitude, and vertical shift. As we work through trig functions, maybe sometimes there's only one change in the from the parent function. Sometimes there might be up to 4 changes from the parent function. So here we go, phase shift. This is what we look for first. This is the order in which we do things. It helps us find our starting point. Phase shift comes from what's added to the variable. Now we're using theta rather than x. What's added to theta? Well, nothing's added to theta, so there is no phase shift. It's not going to move left or right. And so on our graph, sine is not going to move left or right at all. So we know that it will start at 0. That's going to be our starting point for sine. Next, we look to our period. Our period is 2 pi over k, where k is what's multiplied times x, or in our case, theta. So what's multiplied times theta? Well, it's a 4. So the way that we find the period is we do 2 pi, because that is the normal period of sine, over that value 4. And then we reduce. So this is pi over 2. So our period is pi over 2. So I'm going to put a point here for pi over 2. I'm going to mark it. And then we're going to split it into 4 sections. We're going to split it into the quarters. So we split it in half, and then we split each of those halves in half. You don't always have to find these different points in here. I would like you to at least find the halfway point, which I wrote wrong. It's pi over 4. Because if we split pi over 2, or half of pi, we take half of a half as a quarter, and really that actually means this would be an eighth, because you're taking half of a quarter, which makes this 3 pi over 8. And the way that we do that, we can take the entire period, which was pi over 2, divide that in half, so multiply by half is a quarter. That's this value. And then we can also take a quarter and multiply that by a half, and it's an eighth. There are different ways to find those values. Again, that's not the most important thing here. We definitely want our ending point and our starting point. Next, once we use our period to find the ending point, we go to our amplitude. Our amplitude comes from the value that's multiplied by the function. In this case, it's 4. And so our graph is going to go up to 4 and down to 4. So we'll put a 4 up here and a negative 4 down here. I'm going to go ahead and put some dashed lines to show the boundaries of the function. And here's where we graph the function. We always graph after the amplitude. Even if there is a vertical shift, we graph after we know the amplitude. So we know what sine looks like. Sine starts at 0, goes up to its highest point, which in this case is going to be 4. At the first quarter, at the second quarter, or a half, it comes back down to 0. For the third quarter, it goes down to its lowest point. In this case is -4, and then back up. And then this would continue. And so we can graph this function. And we could even go backwards a little bit to the left of the y-axis to show that this continues. So there is the graph of 4 sine 4 theta. I should mention the vertical shift is what's added outside the function plus h. There's nothing added out here. Sometimes it's even added here, like maybe a 3 plus. So it might be at the beginning, it might be at the end, but in this case there is nothing added, so it does not move vertically.